Hey guys, so I'm going to be talking about TDD, test-driven development, which is a software development process where you identify the requirements of a piece of software, write a test, write the code, see that the test passes, and repeat. So we'll go through a quick example here today. I'm not going to go too in-depth. There's a ton of articles already out there, and there's about 10,000 different people that are better qualified to talk about it than me. So I got started writing tests for Ruby and JavaScript, which are dynamic languages, so you miss out on a lot of the compile time safety that you get with .NET. But tests do carry over to .NET, and they can be super valuable when refactoring. I don't use TDD as it's defined for most of my development, but I think doing at least one project with a TDD mindset is a good way to learn how to write code. I did one project where I used strict TDD, and it has really made a difference in how I've written code. The benefits during refactor are incredible. So let's get started. First thing I'm going to do is open Visual Studio. This is Visual Studio 2015 Professional, so if you have a different version, it may look a little bit different. I'm going to be using just the old .NET framework. I've been building a lot in ASP.NET Core, and things work a little bit differently there. Get with me if you want to see an example of how tests are done in ASP.NET Core. So we're going to start a new project. Let's do a console application for now. Whoa, can't spell. Okay. Fire that guy up, and let's see our Solution Explorer. So I'm going to add one more project before we get started to the solution. And if you come down to test in the templates, you'll have a unit test project. I typically just use one unit test project per other project, per main project, and append the name with test. That's just my convention. You can do whatever you want. Let's kill this guy. Alright, now I'm going to add in a class in the TDD example. If you're programming in a dynamic language, you can actually just write the test first, run the test, see that it fails, then create your classes. But because of Visual Studio's runtime bindings, you can't actually build your project if classes don't exist. So we will go ahead and let's just create a new folder, call it models. If Visual Studio doesn't crash on me. Okay, sorry about that. So let's we'll do the classic to-do example, and we'll add a to-do item model. And let's make it public, give it a ID, and we'll give it a description. Okay. So now for the data access. So what we'll do is we will create an interface. Following the repository pattern, which is a whole nother thing. If you guys aren't familiar with it, you can look it up or just ask me. But but this will allow us to abstract away the data access from the actual program. So if this was backed by a SQL database, you can use Entity Framework, you can use straight SQL commands, ADO. That's totally up to you. But this allows us to not worry about that right now. So what we'll do is we will give it a couple methods. Oh, can't assign that here. Get to do item and add to do item. Okay. So now that we've got our interface, we can add a class that implements it. So we'll call this the to-do repository. Interfaces really come in handy when it comes to dependency injection and help make your methods much more testable. Because let's say I want to unit test a method that requires accessing data, I can pass in the interface as a parameter into that method, and I don't have to worry about, and I can create a test implementation that doesn't actually access data. So we can get into that later. So let's write a test. So we come down here to our test project, and let's create a class. That class we'll call to do item repository tests. And this is the convention that I use. I have one class in my test project per class that I'm testing in my main project. And we can use the test class attribute. And this will be totally different depending on if you're using a different framework. But for the most part, they're fairly similar. Attribute names changes, asserts change, but if you're just using the built-in .NET test runner, this should work fine. So there's a nice shortcut here to create a test method, and by my own convention, and there's tons of articles about what's right, what's wrong, but I like to use the method name followed by what that method should do. In this case, I'm testing against the class itself, so I want to say it implements to do repository. And sometimes it just depends on the test method. I'll use a constructor to set up my the object that I'm testing. All right. So a really quick test is we'll assert is true repository is I to do repository. Sorry. Okay. There we go. So let's run our test. You can right click on the method itself or the attribute and say run tests. It'll have to build. There we go. build error, or Control RT. So it builds, discovers the test, then the test runner runs the tests. This test failed. Now you can use your Test Explorer here to see all your tests and whether or not they're failing or passing. And you can double click on it to see where it's at. And why does it fail? Because we haven't actually implemented the repository interface. So we've implemented the interface. Let's see. And let's run our test. And it passes. So that's your first example there. I wrote a test, the test failed. I fulfilled the requirements of the test and ran the test again, test passes. So, now we should go through and test our methods. Let's see. So this is going to test, the requirement is that the getToDoItem method should return a to-do item based on the index. Now a common way to organize your tests is using the arrange act assert hierarchy here, which is, I do all of my setup in the arrange section. So let's create a to-do item. Which we will need to add a reference for. Let's give it an index of 1. And a description of something random. Okay. And we're going to act by calling the repository getToDoItem, todoitem.id, and we want to assert that the result is not null, and we want to assert that the ID is equal. Yep, are equal. Result.id. You put the expected. What do you actually expect? So, which is actually the to-do item and the test. So let's run the test. And the test fails. The test is going to fail because it throws the not implemented exception. So let's go implement it. Let's give it a constructor. Now, like I said before, you would typically use some kind of backing data store like SQL, or you can. This is where you can access data through Entity Framework, which can have any backing database. But for right now, we'll just use an in-memory list to do items. And I want to implement the to-do item, the get to-do item method, which should return a to-do item from to-do items dot single or default. Add our link package. So what this does is it gets the first, if available, it'll get the first to-do item from the list where the index matches, and if it doesn't, it'll return null. So let's try running our test again. And it failed because not null. So I didn't add it to the repository. Actually, we'll do the add method first. So then I can use the add method to create the to add the to-do item to the repository, and then we can fetch the item. That makes more sense. So let's create another test method. Add to-do item adds item to repository. I normally create snippets for this kind of stuff, so then I can just generate these test methods. But I don't have them on this machine. So we'll just copy our test from down here. And we create our to-do item. We are going to add to-do item to the repository. We're going to assert that the return is not null. We expect the to-do item to come back, and we want it to be the same item. We also want the item to be added to the list. So let's run the test. Test fails because we haven't implemented it yet. So let's implement. One thing, the reason we want to return the to-do item from the repository is because if this were the case of a back SQL database, the ID will actually be set by the database, so we want the program may need to be aware of what that new index is, or if anything changes in the object after we add it to the context. So we'll return the to-do item, and let's run our test. Test passes. So let's come down here to our return, our get to do item by ID method, and let's add it to the repository. test passes. So you guys get a quick overview of how you can set up a test for your .NET project. There's tons of articles out there. I'd be happy to answer any questions you guys have. This is very high level, and honestly, you may not see the value in writing tests with an example like this. It seems very rudimentary and not a whole lot of value added. But I can speak from experience that having tests, whether you're doing test-driven development or writing your tests after you actually write your code, having these tests gives you a lot more confidence when you go into refactor. So I can, on some of my projects, I saw a better way to do something, and I tore my whole project down, but it was still standing. So I rewrote all the methods, but they were still functional. They still did the same things that they were supposed to do, and I was able to deploy with confidence because I can run my test prior to my deploy, see that everything passes, and know that my deployment should be much more successful. Other kinds of tests that I haven't gone over are integration tests and system tests. Integration tests are valuable. They take more time to run usually because you have to stand up resources. You can start your web server up. You can actually make calls into the web server, making sure that your middleware, like your routing, is functioning the way you expect. You can write to the database so you can check against database constraints, where with your unit tests you may not be able to do that. So if you have like a unique index constraint on your database, maybe you want to test that. You want to make sure that when I deploy, I can't create duplicates. Another thing I didn't go over here is concurrent testing, which I'm not really sure how many people have ReSharper, and there are other tools besides ReSharper that you can use. So what concurrent testing is when I edit a file that has a test against it, it runs that test automatically, which can save a lot of time. So I did this example without ReSharper. If you want to see it with ReSharper, just let me know. And ReSharper offers a whole other set of tools for your testing. I think that's about it. Let me know if you'd like to see anything else. I'm going to call it good. This code will be available on GitHub. I'll add the link to the message that I send out. Yeah, thanks guys.